So guys, this meeting, I'll quickly wrap up on the concepts that we wanted to learn. And there are some maybe suggestions we can make, or I can make on the design we made, and the reason behind why we did the not optimized way, maybe. And then I'm going to quickly also talk about MCP. What will be our next? What is MCP? Just briefly, what is MCP, and what we want to do, and what will be our next task. Okay, so just let's go with the our backend infrastructure and what we have achieved so far. So the first thing that you do is you click on the extension. The post and get is similar. Let's say we go on the website and we click on one of the conversations. The first thing that happens is we put that doc DNS domain. The doc DNS goes to a DNS resolver, and it will return the IP. And that IP, for example, is this one that you put for your domain. And this IP is going to be a virtual machine. Okay, so it goes here, and then we have this virtual machine. Well, for a virtual machine, we created a virtual private cloud, which gives us a pool of address prefixes that we can assign for our private IP. And there are reasons for it that we need a virtual private cloud, which I'll also talk about. And then we create a subnet. Then we set some rules: port 22, port 80, port 3000, 443. They're allowed inbound. The rule is on top of the entire virtual private cloud. So here we have a VPC, and here we have backend. So we have subnet 1, and then backend. And then here we have a Nginx setup. So user is rich. Well, what we're doing right now is we're putting public IP here. Public IP is directly going to our server, the VM, in the subnet. So I should maybe do it. This is the subnet. Let me create another box. So we say this is VM. Okay, and this is backend, and this is our Nginx in top that kind of does the load balancing inside a virtual machine. And the user, we are basically hitting directly to the virtual machine. And then here, what's going on in Discord? Let me shut down the Discord. Just let me turn off the notification. Okay. So this here. And then another thing we did is we put our backend logic is here, and then we also have our DB here. Okay, we also have our DB here, database, and we use S3 to save the static file. So from here, maybe we do a flash here and a blob storage, blob storage S3. This is our current design, pretty much. Yeah, I don't think, yeah. Am I missing? If I'm missing something, tell me. But that's pretty much our current design. We are not using private IP assigned that we assigned from this subnet to this virtual machine, because we're using public. Nginx takes care of the decryption for 443, and then Nginx routes the traffic to backend, and then DB in the VM, and I think that's pretty much it. But the question I have is, what if, and this is, let's say, this virtual machine that we started with is like, I think T2 tier, which is the free tier. It's probably like the simplest hardware that we could get. But the question is, what happens if the traffic goes up? What do we do? Hey, Jiajun, do you have an answer for this?
So when there are lots of users making a lot of requests, how do we handle this problem?
Yeah.
So we use like some cache strategy.
You're talking about efficiency. That's one way,
Okay.
right? That's one way. Let's say we have the most efficient tool, logic, everything. So one way would be just get expensive hardware. So I think we have free tier, but like there's way more expensive tiers that you can set up your virtual machine. The problem is, let's say the spike in user traffic only happens in holidays. But then it doesn't make sense to get that expensive hardware because it's sitting idle most of the year. Just want to make sure those holidays, maybe December, right, and those kind of events that you have a spike, you can handle the traffic. So I would say we just go with our normal hardware that most of the year is able to handle it, but then we spin up another VM when there's traffic. I think that would be one solution. It's pretty much the most common solution, actually. So let's do this, okay? Let me give this some space, and instead of directly reaching out the VM, we put an LB here, load balancer. Okay, so we have an LB here, and we have subnet 1, subnet 2, and VM1, VM2. So, and then, yeah, this is reaching out to these VMs. The load balancer takes care of that. 1 second. Okay. So usually this is how you design it, unless you're a startup. And this load balancer has the IP for you. It has like a public IP, right? So you have IP here, you have a public IP and load balancer has, and then you set some backend rules, which we'll talk about. And then you give this pool of backend servers that the load balancer is going to route the traffic. So what happens is instead of doc DNS be direct access to your VM, you're going to put your load balancer IP here. Okay, so you reach out the load balancer and you have some rules that based on those rules, it's going to spin up another VM, or it's going to auto scale. It's going to scale out or it's going to scale in, right? So let's say traffic is gone, it's going to shut down one VM and it's just going to stick with one VM. So out of two, you will go back to one because you don't want to waste money, right? If you don't have the traffic. Right now, we took care of just one VM. In order for the load balancer creates another VM, you have to give the entire instruction of how to, like whatever you did for one VM, you have to give that instruction so it replicates. And I was looking at EC2, I was looking at Amazon. There's different ways. For example, you can even have Docker, set up Docker, and then you create an image, and then you just give that image for the AWS to use it, to use that in the Docker, and then basically has all the logic that you're using. But in our setup, we didn't want to go with the containers and Docker. I think that just gets too much into infra stuff. And it's not really a common thing. I mean, containers are being used, but even at Microsoft, we also have virtual machines. We don't use necessarily, we don't use containers for scaling in and out. But I'll just briefly give you guys like a example how you would do it if this was your virtual machine and you want to make sure it you give it some requirement for it to scale in and out. So here you have instances. There's one thing you can see here is launch template. Okay. You can create template. That being said, I think if I go to the instance itself, I should be able to create a template from the instance I already have. Create template from instance. Let's see if that works. I put test version, like version 1, for example. Yeah, you can see it already picked Ubuntu, right? So you want to tell the load balancer, use this template, and this template already has all the information that you use to create your first VM. T2, right? We want to just scale out with the free tier we have. The key for the logging, we want to use the same key, right? Subnet, use the same subnet, use the same security rules. Pretty much everything is written. These VMs, right? They need to be completely identical. We just wanted to scale it out to be able to have more VMs to take care of the logic. So everything needs to be identical. And then you create the template. Say we create it here. And you go to your template. You have everything there. One thing I do need to look. Yeah, one thing we miss here, I wanted to explain about user data. So it has an option for you as a user data. What does it mean? Is okay, I give a template for the load balancer to set up a virtual machine with Ubuntu. But how about my logic? How about my backend server? How about the Nginx? How about the systemd? This is where you define it. I think you can just upload a YAML file, basically similar to our GitHub action, except GitHub, yeah, very similar to GitHub action. The steps would be cloning the GitHub. So you give it, you give the repo. If it's public, then it's okay. If it's private, then you probably need to take care of authorization for it to be able to authorize to your GitHub and access to your repo. But it clones your GitHub. Then you just go step by step, install Node, you set up your systemd, and you reload systemd, and then you have your VM setup. So that's the configuration you can have here, right? And this would be your full end-to-end template. You don't need to do this. By the way, this is out of scope of this project. I think it will be too much into infra stuff. But I want you to not just theoretically try to understand this, but like if you actually wanted to implement, how would it look like? Then there's autoscaling groups. Now you have the template. You create autoscaling groups. Let's say LB, right? You give it the template. The template, it gives everything for the load balancer to set up the virtual machine. Your backend, that goes to user data, and then the configuration of the virtual machine itself, AWS auto creates for you. If you go to instance, right, create template from the instance, it will create it for you. You just have to have a YAML file, which the steps to take to get your logic installed. But what I want to show you guys is, let's say we also have 3 availability zones, and we allow it to create virtual machine in any of it. But what I want to show you guys is, oh yeah, we do need to create a load balancer. So this is a scaling rules that we are assigning to it. We do want to create a load balancer for it. And this is the listeners and routing I was talking about. So you can create a target group for your instances. I think instance target group with default setting will be created. I think you can initially create it, but you have to edit it and make sure you're targeting the EC2 instances that you have. Let's say for now is this. So what it does is it your traffic on port 80 lands on your load balancer, and default routing forward to, it means the backend part of it, right? Where do you want this traffic to be forwarded to? This is just a load balancer, right? The load balancer part. But we need to define when this scaling happens. So you take care of the load balancer. You can also do some fancy stuff like health check, because sometimes your VM, one of the VM for some reason might be down. So you want to check the health of all the VMs. And you don't want to route the traffic to the one that is unhealthy. This is the scaling rules we set. So one, usually for startups, one would be sufficient. For scale up, for example, Microsoft, our minimum is 20 and our maximum is 100. Literally, when there's a spike, we might have 100 of virtual machines running at the same time. And then, the scaling policy, there's different metrics you can track for it to check and scale based on that. The most common one is CPU utilization. So you can say CPU, when it reaches to 70%, that's when I want you to spin up another VM. The rest are fine. And then that's pretty much it. It can give you notification if it hits that limit, and then tags, and then you create. And for your dog DNS, you just put the load balancer IP, right? Because you don't want to go directly to virtual machine anymore. You want to go to load balancer and let the load balancer to do the scale. So some work there if you want to set it up in a way that it scales in and out. And this part, almost for every system design interview, is the most common part, right? You always, when you design your backend, you always put a load balancer and you talk about the scalability. Because if you just put one virtual machine, then that's a red flag. You say, okay, what happens when there's a spike? But when you just put a load balancer, you say, okay, I just set the rules. Probably the metrics in our case, because for example, in our case, we are doing scraping, right? And we are looping through the nodes. So there's some CPU utilization there. And then we are saving in S3, we're saving in the database. There are some async requests that's happening. So if there's a lot of users that they're making those requests, then the CPU is doing a lot of looping through the nodes and making a lot of calls. So CPU utilization is probably a great metric for us to realize that we need to scale in and out. So that would be, for example, something you can bring up in the interview, and it will show that you have some experience. That's pretty much it for this site, right? Now we have it set up in a way that it can take care of spikes in the usage. And then we can set minimum 1 instance and maybe 10. That also is based on the data you get over time. For example, at Microsoft, we have 100. It wasn't 100 initially. It was 10 initially. And then we realized, okay, now we're keep hitting that 10. Let's go to 20. Now we're hitting the 20. Let's go to 50. So just over time. There's no way of figuring out initially what's the max. And mean you don't want to go below 1 because then that means if there's no traffic, your virtual machine completely dies out. And then if someone tries to reach out, there will be a cold start. Cold start means there is no VM and your AWS needs to set it up for you before it's able to handle your request. You don't want to have cold start usually, at least not for your backend logic. Maybe some different logic that they run, like some periodic work item, those can have cold start. It's not that important, but not in this case. But there's a problem here. So we say we put the steps for our backend into our template, which is cloning GitHub, setting up systemd. Totally fine. But how about the DB? How about the database? Paul, do you want to speak up on the database, for example? What do we do for the database? Let's say it's just one virtual machine initially. And we have our database that says 1 gigabyte, there's 1 million rows. What do we do? Should we just like copy and paste it here in the new virtual machine? Would it make sense? So probably not, right? Cloning your logic makes sense that you're creating a new virtual machine, you download your logic there, whatever the size is, and you run it. But database over time is getting bigger and bigger. Are you going to, when you set up a virtual machine, are you going to download 1 gigabyte of data from here to here? And then what happens to the saving part? Let's say load balancer gives some request to this one, and then gives some request to this one. Which database are we going to trust? This one is going to have some data. This one's going to have some different data. Right? They will diverge at some point. So we did it that way just because we wanted to learn and we didn't want to deal with too much infra work. But the right way is you don't set up DB in your server. Server always has to be stateless. You do not want to save data in your server. What you do is you create another subnet. Okay. You create another subnet, let's say subnet DB. This is just specifically for DB. And then this virtual machine is only as our Postgres database. And the way we take care of it is, it doesn't have Nginx, it doesn't have any of those. It's just one time, no scale in, no scale out. Okay, that's not how database works. You don't scale in and out the database. Database is one machine, you keep it, and if it's running out of space, you create another virtual machine and you start partitioning your data. So then you can track in which machine it exists. You don't scale in and out because database is your source of truth. You can't have different DB and they receive different requests, right? Database is an entity that needs to be a source of truth. Every server that access to it has to see one similar data. So there's no Nginx here. We don't need Nginx. We just use the Postgres IP and we use a private IP and we try to communicate from these backends with private IP. DB private IP. Why private IP? Well, database is important, right? We don't want to mess it up. We don't want to have exposure to public. Also, there's no reason for this to have a public IP and public access because our backend is the one that needs to have access to the DB. And they are within one virtual private cloud. So instead of using public IP, we can just use the private IP of this virtual machine. You remember in our server, we had the logic, we were using some sort of, I think we were using like localhost, maybe a DB port 5000 or something there. Instead of localhost, because this is not within the machine, it's outside, we just use the private IP of this virtual machine. And for inbound rule, we do not allow internet traffic. We only allow internal traffic and only the port of the DB, right? That's the rules we want to set. So this way, we have our security also in place. No one can access our database, only our servers. And the reason they can access it is because they are inside one virtual machine, virtual private cloud, or in Microsoft, we call it virtual network. So just similar concept, but different names. I guess now you probably have a better understanding of why we needed a virtual private cloud and subnet for our virtual machine. Because of this flexibility that it gives you. It gives you this isolation, right? Even for here, load balancer can have a public IP, but even for virtual machines, we can remove the public IPs and only give private IP, because load balancer can have access to the private IP and be able to pass a traffic to private IP. So now you're probably getting a better understanding, right? Because initially you're like, okay, well, what's the use of this private IP? If as a user I can reach out to private IP, then what's the use, right? Well, that is the use. For so some services we just need the backend to have access to them, and they do not need any exposure to public. So this would be probably the right way to set up our database. But again, it's the same process. I didn't want you guys to be involved in creating another virtual machine and then doing everything from scratch there. But same setup that you did here, you just have to create another virtual machine. That would be the right way of doing it. Okay. Now, remember I said the reason we do in S3 is because uh, S3 has this feature that it can push your static files to CDN, which is also another storage. But the reason it's called CDN is because um, it's basically a storage that exists in a lot of different regions, right? So it pushes in different. By the way, this website this is usually what I use to do my system design interviews. And if you have done it, probably you're familiar, but it's like very popular. Let me open my Discord again. It's very popular software and free that you can use for practicing and doing your system design interviews and all that stuff. Just put this here so you have it. So that way, um, the backend, so for the database, right, the metadata we have, they are very light. You probably reach out to backend, do some query, and then get a URL. But the static file, that conversation can be as long as 1 MB, can be 10 megabytes, right? It can be a long conversation. That's why for optimization purposes, we put in S3 and we push in CDNs, because if let's say someone in India, this is the user from India, reaches out to the load balancer, goes to backend, you pass that record ID. Record ID goes to Postgres. It gives you this just like a string of your S3 link, and when you return it, the user starts downloading that 10 megabyte content, right, from a location close to it. So this is also a very common way of optimizing, because it saves potentially a couple of seconds rather than the user reaches out to S3 in US, for example, because we're talking about bigger scale of data to download when it comes to that static file. That was optimization we did there. What else is there? So what do you guys think? Any optimization that you guys come to your mind, or if any part of it is missing? Also, I can think of what else we did and what other efficiencies we can do. Oh yeah, so maybe so for example, in case of Gemini, when Chance was working on it, he already had all the styles in the website, so he would get it and he would just put it part of the conversation. But some of you don't have the styles; you have it as a link, and well, it's acceptable to just pass the link, and it works. But one optimization is for that model, you download that content one time and you save it into, let's say, a memory into your machine. That way, if you try to download, for example, Meta, if you try to download those styles from those links, it might take up to a couple seconds to download the entire thing. They're like large files, right? And imagine you're adding that for every scraping. Well, let's say you do it one time, you save it into memory, and next time you get the conversation, you have the style and you append it. You don't download every time, right? So that's like one optimization that can happen. But overall, I think this for our scraping algorithm looks pretty decent. Um, and at least I can say it's acceptable, right? Maybe, and especially for you guys, we're not talking about senior design, right? Very detailed to handle a global scale. But for you guys' level, I wanted you to at least understand these very common and kind of basic concepts. Okay, just this much I wanted you guys to understand. And beyond this, it's more about database. Okay, database, you said you don't scale in and out, right? But let's say we do need to partition it. Like talking about that, there's like more senior level would be talking about this part, the database. How do you partition? How do you make 10 of it, 10 virtual machine? Which partitioning is one way, but how do you partition? There's some logics and algorithm for partitioning. That can get like more advanced topic. Other than that, I guess more advanced would be around the database. Yeah. I guess for our scraping, that's pretty much it. Maybe for a topic like Ticketmaster, maybe the more advanced question would be, how do you handle if a user, let's say conversation you could have modified. One user goes to the conversation and tries to modify it, and another user at the same conversation tries to modify it. But that modification goes to this VM, and then the other modification goes to this VM. How do you make sure they don't overwrite each other into the database? For example, that would be one advanced topic. But pretty much, this is all you need up like junior to mid level. These are the concepts you need to learn. Okay. Now, I want to talk about MCP.